Alright, so you guys can grab out your 6-7 notes, and today we're going to be talking about parallel and perpendicular lines. So to start off, we will do some vocabulary. First vocabulary word is parallel lines, and parallel lines are lines that never intersect. So here's an example of parallel lines. They're going to keep going on forever and ever, never going to cross paths. A lot of times, in order to shorthand the word parallel, instead of writing out parallel, you might see this symbol, and it's just two parallel lines. That stands for parallel. And I remember that parallel lines never intersect, because if you look at the two L's in the word parallel, the two L's themselves are parallel. So in the name parallel, it gives you an example of what parallel lines would look like if you look at the two L's. And our second vocabulary word is perpendicular lines. And perpendicular lines are lines that intersect at 90 degrees. So perpendicular lines create a 90-degree angle, and we use a box to represent a 90-degree angle. And when they intersect, they actually create 4 different 90-degree angles. So all of those corners are 90 degrees. And for shorthand for perpendicular, you might see this symbol right here, and that stands for perpendicular. And then last but not least, the word reciprocal should sound familiar. We've gone over this in the past. If you were to write a reciprocal of a number, so say we're starting with like the fraction 2/3, the reciprocal of 2/3 would be 3/2. You switch the numerator and the denominator around to have the reciprocal. Now, one interesting point that I want to point out about parallel lines is if you take a look at parallel lines have the same exact slope. So the rise and the run has to be the exact same for parallel lines. So for parallel lines, you're going to want to write same slope. And that's a very important point to keep in mind. Parallel lines have the same slope. You're going to increase or decrease at the same exact rate. And that same slope is what prevents those two lines from ever intersecting. Perpendicular lines, though, because they do intersect, they do not have the same slope, but they have what we call the opposite reciprocal. Slope. Opposite reciprocal slope. And an example of opposite reciprocal, let's say that our slope were 3/4. So one of our lines was rising up 3, running over 4. The opposite is saying to change the sign. So this is a positive 3/4, so we need a negative 3/4. And then reciprocal tells us to flip the numerator and denominator. So these would be the two slopes. Opposite sign, and then the reciprocal. And that's what causes them to intersect at that 90-degree angle. So for example 1, our question says, are the graphs of y equals negative 2x minus 1 and 4x plus 2y equals 6 parallel? So in order to determine if these graphs are parallel, we are looking for the same slope. So the only thing we care about in this example is what their slopes are. In this first example here, I have y equals mx plus b. So I can see that my slope is a negative 2. But in this second equation here, this is actually currently written in standard form, 4x plus 2y equals 6. And so what we're going to do right now is actually convert this from standard form to slope-intercept form. And that's going to tell us what the slope is. So my goal is to get this equation to say y equals mx plus b. So I like to write my goal at the bottom so I know what I'm working to. And I need to start off by getting this 2y by itself. So this is a positive 4x. I'm going to go ahead and subtract 4x. Subtract 4x. I get 2y equals. Now, since I want my equation to say mx plus b, I'm going to go ahead and put this in negative 4x first, because the x's come first. And then I'm going to write my plus 6. And then to finish getting y alone, we're going to divide all three of these pieces by 2. Negative 4 divided by 2 is negative 2x, plus 6 divided by 2 is 3. So I just converted this to slope-intercept form. And I can see now that it's in slope-intercept form that my slope here is negative 2. My slope up here is negative 2. So to answer the question, are the graphs of the lines parallel? The answer is yes, they are parallel to one another. So I'm going to have you go ahead and pause. Well, actually, let's do number 1 together. Our directions are slightly different here. We have to find the slope of a line parallel to the given linear equation. So we are given this equation for number 1, and it's currently written in slope-intercept form. Y equals mx plus b. And we want to say what a parallel line, what its slope would be. So I'm trying to figure out what would the slope be of a parallel line. Well, for parallel lines, we have to have the same slope. So I'm going to go ahead and write m equals, because I'm looking for the slope. And then this equation is already written in slope-intercept form for us. My slope is currently 1/2. So a parallel line would have to also have a slope of 1/2, because parallel lines have the same slope. And now I'll have you go ahead and pause the video. And for number 5, I want you to find the slope of the parallel line to this given equation. All right, so for number 5 here, this is currently in standard form. My goal is to write it in slope-intercept form. So if I want to get this 4y by itself, this is a positive 3x. I'm going to go ahead and subtract that 3x. So I have 4y equals negative 3x plus 12. Divide by 4. And I get y equals negative 3/4 x plus 12 divided by 4 is 3. So my slope is this negative 3/4 right here. So if I wanted to make a parallel line, my slope would also have to be negative 3/4 because parallel lines have the same slope. And I'm going to start up a second video for the remainder of our